Okay. All right. We're going to look at perpendicular bisectors. We have a triangle here, and we're going to find a perpendicular bisector. And you know what? We'll find it from line CB, we'll say. So we need a perpendicular bisector for the side CB on this triangle. So what does that mean for us? We'll actually start with the second part of this word. A bisector means it's going to cut something in half. So we need to find, we'll call it a midpoint. That's going to be an important part of this, finding a midpoint. It's the cut in half is the bisect, but perpendicular has also got a very specific definition. What that means is it has to be a line that goes through this, and I don't want to go through the A point, not because it's not right, just because I don't want to emphasize that. It has to make a line that's actually makes a right angle with the side of the triangle called CB. So it may not go through point A, it may go through point A, but that part's not important. So the first thing we can work on is the midpoint itself. What is the midpoint? Oh, there he goes, using the wrong tool. What is the midpoint between C and B? You might have a midpoint formula, it looks like this. Midpoint of CB. Sometimes I write it like this, the X value of the midpoint and the Y value of the midpoint. Essentially, both of these are equal to a formula like this, x1 plus x2 divided by 2. That's just finding the average between 2 points. y1 plus y2 divided by 2, okay? What 2 points are we referring to? Well, since it's the midpoint between CB, we need these 2 values. So we'll say C, which is -2 and 1, and B, which is 2 and -2. We're going to label them. I'll call C.1 and B.2. It doesn't really matter, just for labeling's sake, so it's easier to plug into that equation that we have. But since we called C1, we'll call that x1, y1, and B, x2, y2. So our x1 here is going to be -2. So we get -2 plus our x2 is the value of 2 divided by 2. y1 is the value of 1, and y2 is -2, so plus -2 is the same as saying subtract 2. When we sort it out, this is actually 0/2, and this one becomes -1/2. Okay, so we end up with 0 and -1/2, or -0.5. I'll write it this way too, just so in case you have a preference. And we'll take a look at that. Our midpoint is, did I write that right? y1 plus, oh, this should be y2. Yeah, I guess I wrote that right. It just doesn't look like it's correct. In fact, no, that can't be correct. It should be 1.5, I believe. If we quickly look at this sketch, you can tell this one's, oh, that's the problem. There we go. This is mislabeled. That should be -1. Okay, so if that's -1, my goodness, I picked that up. There we go. This should be 3/2, which makes us, there we go. I knew our visual, I'd actually made it to scale, so I knew there was something off there. Okay, 1.5. Either way, we have a midpoint. That's key. The reason it's key that we have a midpoint is we now have a point on this line, this perpendicular bisector, okay? So we have a point on the line. So a perpendicular bisector is essentially finding an equation of some line. So y equals mx plus b. We need to find some line, and we're going to have to find both the slope and the y-intercept of the line. What's neat is we've actually found the y-intercept of the line, so we can kind of cheat our way through the rest of this, but I'm not going to show you that just in case that doesn't happen. We happen to fluke one where the midpoint of CB happens to also be a y-intercept. Let's say we weren't aware of that. In order to find the slope, we know the slope has to be perpendicular. Well, we only have one coordinate on this line here, that's the perpendicular bisector. But I actually have 2 coordinates on CB. So strategically what I can do is I can find the slope of CB, and then I can just find the perpendicular slope to it. There's a little trick to find perpendicular slopes. So we're also going to use CB again just to find the slope of line CB. And I don't need the y-intercept of it, even though I actually already have it. We're going to say our m slope is equal to y2 minus y1 over x2 minus x1, okay? We've already labeled everything, so that works out really nicely. Y2 is -2. Y1 is -1. So minus -1 is like adding 1. X2 happens to be 2. And X1 happens to be -2. So subtract -2 is like adding 2. We end up with -1 over 4. So our slope is -1 over 4 in this case. This thing has a positive slope. Oh, that makes sense. Yeah. Because we're talking about the slope here. That makes sense. So we have a -1 over 4 slope. Okay? We have to find something that's perpendicular. So what we can do to find a perpendicular, we actually find the reciprocal. So we flip it and we multiply it by -1, whatever it is. So in this case, this is our slope of CB. To find the reciprocal, we're going to flip it. So it becomes 4 over 1. And technically it's -4 over 1 times -1 will give us positive 4 over 1. Or I'm going to write that as just the number 4. So now when we're trying to create our equation of our line, I'm kind of running out of space here, so I'm going to move down. We know the equation of our line is y equals mx plus b. Our slope for our perpendicular bisector is actually just 4. It's a nice, easy number to work with. Nice whole number. So we get 4x plus b. Now we technically already know the y-intercept. I can already plug it in. But let's say we didn't. Or let's say this wasn't a y-intercept. How would we go about finding b? Well, this midpoint is on the line. We can sub that in for both the y and the x value. And we can isolate for b. So that's what we're going to do here. We're going to substitute this point here. Remember, that's the midpoint. That's the x value and the y value, -1.5. We're going to plug them in. So we'll replace y with -1.5 is equal to 4 times, replace x with 0 plus b. This becomes -1.5 is equal to 0 plus b. Turns out b is equal to -1.5. So now we want to write the full equation, which would be y is equal to, our slope was 4 from before, and this time our y-intercept, which again we already knew was -1.5. So this is the slope of the perpendicular bisector to the side of the triangle that's called CB. There is technically 2 other perpendicular bisectors that we can find here.